Okay, good day to all of you, and welcome to this lecture on closure, rehabilitation and expansion of landfills. So, we've been talking about a large number of garbage dumps being there in all the cities. One is we want to design new landfills, so we'll make a liner, we'll make a cover, and we'll do all the design that we've done. But what do we do with all the large old waste dumps where a lot of waste has accumulated near the cities, inside the cities, just outside the boundaries of the cities? So that's what we are going to look at today, that how do you close old waste dumps? And you remember in the beginning I had shown you a large number of photographs of these small mountains of waste in various cities that we find. So what would you like to do with these waste dumps? Well, ideally we would like them to disappear. We would like to be able to utilize the waste for something, and that land area beneath the mountain should become available to us for utilizing it in a proper manner. Making a playground, putting a shopping mall, putting a hospital, putting a school. I want to release that land from the waste. So ideally I'm wanting to completely make that waste vanish. But then where will the waste go? We've done integrated solid waste management principles. We can reduce waste, but we cannot eliminate it completely. So let's see how we tackle this problem. What do we mean by the term closure? What do we mean by the term rehabilitation? And we'll take it from there. So closure, rehabilitation and expansion of municipal solid waste landfills. Now you will find a few words. Control or control measures at old waste dumps. It means I have to do the containment such that the contamination remains in the area and does not spread further. So control means I know that a waste dump is causing contamination via the air route, via the surface water route, via the groundwater route. I want to adopt measures that it does not extend beyond what it is today. That means I've controlled it. That is called control measures at waste dumps. Remediation is the other extreme. Remediation is I want to bring back the site to its original condition. I have to make the waste vanish. If there is already, even if I remove the waste, there may be contamination below. I have to remediate that. Suppose the groundwater has got contaminated by some chlorides, I have to remove those chlorides. So I have to bring back the site to the original condition. Extremely expensive, not often doable. But that's what you mean by the term remediation. People tend to use words interchangeably, but that's not the case. What is closure? Closure is same thing as control, but the waste dump remains where it is and it is capped or encapsulated in a suitable manner. So in control measures, you may remove the waste. Suppose you have a small amount of waste lying over an area of 50 meters by 50 meters. So your control measures may include removal of the waste. Whereas closure means you have a large waste dump, it's too expensive to move the waste, you will cap the waste dump, you may put other measures for controlling the contamination from spreading, and that is the term closure. And is rehabilitation the same as remediation? No. Rehabilitation means control measures, but do something such that the footprint of the waste is reduced. You have a waste dump which is occupying 1 kilometer by 1 kilometer area. Can you do control measures to stop the spreading? Yes. But can you also do additional measures of remediation such that half that land becomes available to you? So that is rehabilitation. Closure means you cap it or put the vertical cutoff walls or whatever measures for containment that you want to take. Rehabilitation means not complete remediation, but your first set of steps trying to release the land which is buried under the waste. So rehabilitation means control measures plus some remediation to reduce the footprint of the waste and allow limited use of the land. These definitions are not well described anywhere. These are the words that I've come across. Many are used interchangeably, but we would like in our discussions to follow these definitions for the purpose of this lecture. Always remember, remediation is very expensive, closure or control is less expensive. So just to recall, I have old waste. We've done this earlier. There's groundwater at the bottom. When the rain comes, leachate may be formed and you may have a contamination plume. So as a measure of to prevent further contamination, I might put a cover. If I put a cover, then the rainwater will not infiltrate into the waste. To further prevent, even if I put the cover, this plume can travel downwards with the groundwater flow. To prevent groundwater flow from traveling downwards, I may put vertical cutoff walls. We will look at what are these vertical cutoff walls in a subsequent lecture, how do we make them, but these are vertical impermeable walls. Not of concrete, because concrete is rigid. These are more like vertical, flexible, impermeable walls made of low permeability soil, and we'll look at them later. So now I've contained the contamination. The air route is blocked because there's a cover. The surface water route is blocked because the water doesn't come out from the sides, and the groundwater route is blocked. So the three pathways are blocked. Ideally, of course, I would also like to completely eliminate this, because I don't want to learn that no, this plume went down with time and you had a hanging wall and therefore it bypassed. So the tendency to make vertical walls very deep is always there, but you may not find an impervious strata at the bottom. It is possible to make an impervious stratum, an impervious barrier at the bottom of a plume. It's exorbitantly expensive. It is not done. But technology is there if you want to make, including going and tunneling underneath this and making a barrier. So what normally is done is, instead of putting a barrier at the bottom, we put an extraction well and keep the water table level inside lower than the water table outside, so that the flow is always inwards. So therefore, you have assured that the contaminant plume will not fall down and bypass you. You are able to allow, since the water is flowing inwards, the plume is not going to drift towards the direction of the groundwater flow. So let us look at the situation in India. Each major city of India has at least one operational dump. Now, how many operational dumps in Delhi? We have 3 operational dumps, one at Okhla, one at Ghazipur, and one at Balaswa. So we have 3 operational dumps. Bombay has 2 or 3, but every big city will have at least one dump which is operational, and there is immense public pressure to close or rehabilitate these dumps. You see, in the beginning, the dumps were outside the city limits, but cities have expanded, and what happened? These dumps came within the city limits, and therefore there is an emphasis now, of course, on reducing the waste reaching landfills and placing the rejects in well-designed landfills. If I take top 20 cities of the country and look at the 30 odd operational waste dumps, what data emerges from India? What is the kind of areas that we have? 53% of the waste dumps are in the area of 0 to 20 hectares. 1 hectare is how much? 10,000 square meters. If it is square, how much is 10,000 square meters? 100 meters by 100 meters. That's like a football field or a cricket field. So 0 to 20 cricket fields. Most of them are in that range. But there are some which are bigger, 20 to 40 hectares. There are 40 to 60 hectares and even greater than 60 hectares. So bulk of the dumps are less than 20 hectares. What kind of heights? Most of the dumps are 0 to 10 meters. Okay? Many are up to 20 meters. Some are up to 30 meters, and we have even above 30 meters. So in terms of area, the largest waste dump is Deonar at Bombay, which is 120 hectares. Not bad. 100 football fields put together. And the Okhla in New Delhi is the highest. Ever you want to take a leisurely walk or a drive, go to Okhla, have a look at the Okhla waste dump. It's now touching 60 meters, and just to remember, Qutub Minar is 74, as I said. So who will win in the end? I don't know. And they have several million tons of waste in them at the present period of time. So how bad are they in terms of environmental impact? The question is, how close are they to the groundwater? In 29% of the dumps, the groundwater is between 0 to 5 meters below the ground surface. That's pretty bad. But in many dumps, the range is 5 to 25 meters, and in others, more than 25 meters. Distance to surface water body, typically within 500 meters, if you recall, that's the buffer zone. Some 39% dumps have a water body in the buffer zone. If you have a lake, you are in the buffer zone and your ground is sloping towards the lake, because lake is in a low-lying area. And the surface runoff, leachate is going to go into your lake and spoil it. But luckily for us, most of the water bodies, that means 61%, are more than 500 to 2 kilometers away. So they are a little further than the buffer zones. But how close are our dumps to the cities? 62% of our dumps are either in the fringe of a city, or on the side of a city, or in the middle of a city. That's the worst part. So being in a city, if your water table is deep below and you got clay, it doesn't make effect to the groundwater. If your river is 5 kilometers away, but being in the city, there is smell, there is fire, there is smoke, there is dust, there is litter. So air is the biggest problem. Groundwater can also be a problem if you are sitting on a pervious soil and the water table is shallow. But in the city means a lot of problems. So out of these 29 and 46, which means 75% waste dumps, please note that the 50% of these dumps are on alluvial deposits. Alluvial deposits mean silty sand, sandy silt. So their water is between 25 meters and the subsoil is pervious. That's trouble. If it was 20 meters but you had clay, you could be safe, because the rate of travel of leachate, as we have done, is pretty slow. So objective is to minimize the impact of the existing waste dumps, and hue and cry is always about smell and odor and dust and fires. Reduce the incoming waste so that you can put more waste in it, in the sense that your life becomes longer. I mean, what a capacity which is finishing in 15 years, can you extend it to 30 years? Minimize the base area of the existing dump. We saw many of the dumps are between 0 to 10 meters high. Well, that's not an efficient use of the area. We are saying from an aesthetic point of view, you can have a dump which is 15 meters high, and you really are short of space, you can even take a dump higher. So you have a 10-meter high dump, you are using double the area. You make that 20-meter high, you can release half the area. So minimize the base area of the existing dump to accommodate reduced incoming waste in new well-designed landfills. And wherever there are old dumps, please stabilize them, so that the recent failure was in Brazil, the one which we talked about a few days ago, where 40 people died. So stabilize the old dumps and allow limited access where feasible. So what are the alternatives for closing a dump? I have this dump. The simplest and the cheapest alternative is to grade it and put local soil on top. Out of sight, out of mind. Beautiful grass, please grow beautiful green grass, and say, I have rehabilitated the dump, I made a park instead. It doesn't always work, but this is the cheapest and one of the alternatives, which there's a tendency of municipal corporations to adopt this. But then instead of a single soil layer, maybe you'd like to put the municipal soil MSW cover, which we have done. There are the guidelines for it. It will have a topsoil, a drainage layer, a clay barrier, a gas collection layer, and then the waste and passive vents. So this is the second alternative. You want it to be more impervious, you don't want any water to go in, you might use a hazardous waste cover. That means now you've added on a geomembrane. Because there is no liner, this is not a landfill. if this was a landfill, this cover is fine as long as there is a liner and a leachate collection system. But this is an old dump. What else can we do? And this was just recalling that this is the MSW cover and this is the HW cover which we can adopt. However, you may want to actually completely eliminate the odor and the greenhouse gases, because if you are putting a hazardous waste cover with passive vents or a municipal solid waste cover with passive vents, the greenhouse gas emissions are still taking place. So then you might want to have a treatment or a flare or a heating or a waste to energy unit. You may collect gases using wells and other things. So this is yet another alternative. If your groundwater table is closed and you are sitting on pervious soil, just by doing all this, nothing is going to happen because the plume is already moving. If the plume is moving, then you need to put vertical cutoffs. So this is yet another alternative. Agreed? And if you have a little bit of land on the side, maybe you'd like to put this dump into a new landfill right on that area or adjacent to it, or maybe a little far away. Expensive, but can be done. It's an alternative. It's for the community to decide whether they want to do this or not. But the ultimate rehabilitation which is being talked about today is, if you have a dump, you please mine it. Remove this, take it out. If you can get energy, burn that portion, take out the waste, fractionate it using different sieves. If you get a lot of cloth and plastics and paper, burn it. If you can get compost out of it, that means old soil with organic carbon in it, then you can use it as a compost. If you can get building materials, construction and demolition waste, which you can use as aggregate, use it. And finally, this huge dump should become this small rejects. This is called landfill mining, and this is rehabilitation. It's not remediation still, because you still are going to occupy the land with the smaller landfills. So these are the alternatives which exist as far as closure is concerned. Any questions? Any doubts? Any other alternative which comes to your mind? You can become progressively stringent. That's what I'm saying. So I put those 7 alternatives: local soil cover, municipal solid waste cover, hazardous waste plus gas treatment, hazardous waste plus gas treatment plus groundwater, pump and treat with slurry walls, put in a new municipal solid waste, mine and put in new municipal solids. These are the 7 alternatives which are increasingly expensive as you go down. Now, if you have a landfill which is having one high impact, can you tell me when will the groundwater impact be high? You have a waste dump. When will you say that in this site groundwater impact is high, or no, same waste dump, here the groundwater impact is low? So what are the variables which you will consider for groundwater impact? Well, the first is, where is the groundwater table? Is it near or is it deep below? So if there is no groundwater in the first 100 meters below, then groundwater is not an issue. But if the groundwater is 5 meters below, groundwater contamination is an issue. And as rightly said, the second issue is, are you on permeable strata? And the third is, are you in a high rainfall area? So if you have pervious soil, shallow groundwater table, high rainfall, groundwater can be impacted. Just flip it around, when will it not be a major problem? You have clay. Water table is not at shallow depth but deep below, and you are in a relatively arid climate. Then groundwater contamination is not a problem. That does not mean other things are not a problem. If groundwater contamination is not a problem, you can have odor as a problem. So, first what we see is, groundwater contamination is a high impact factor if you have shallow water table, pervious soil, and you can add high rainfall. When is surface water contamination going to have a high potential? When you are sitting adjacent to a water body. And worse, if you are sitting adjacent to a water body where the water is not a running water. So if you have a lake or a pond, then water is not being, if you have a river, water is flowing by. Some contamination will go, it will flow down. But if you have a lake or a pond, you're accumulating water. And if some black, dark brown colored leachate goes into it, it will contaminate it. So surface water contamination immediately is a problem. If you are near a lake or a water body, you have sloping ground. When is air contamination a problem? When people are around. I have a dump which is in a very remote area. It will create smell, it will create dust, litter, smoke, fire, greenhouse gas. But there are no people around it. So if the receptors are not there, it is not that major a problem. You have a much smaller dump in the middle of a city. Huge impact, because the receptors are getting all kinds of problems. You're getting air pollution, the quality of the air is falling. So air contamination in terms of bad odor, greenhouse gas emissions, fire, smoke, when the dump is within the city or it's very near to communities, is a big problem. And it's not an issue about the dump being small or big. You have a source of smell, it's going to be typically that smell is significant up to 1.5 kilometers. And depending on wind direction, it can be up to 3 kilometers. So, these are the type of situations in which you can have different impact. The same waste will give you different impact. What happened in Brazil? Slope instability. Why? Steep slopes, dwelling units were on the slope. You have a high impact of slope instability. Aesthetics. You have a high and large dump. The dump is this big and the dwellings are this small. So you drive up to it. And for each of them, there is a solution. We have talked about the control measures and there's a solution. And just for aesthetics, a vegetative cover is fine. But if you have groundwater contamination, you need a highly impervious cover, hazardous waste cover, vertical cut-off walls, and pump and treat. Surface water contamination, highly impervious cover, intercepted drains so that the leachate doesn't grow along the ground to the lake, on and below the ground surface. Air contamination, highly impervious cover, but collection systems. Collect the gas, collect everything. Burn it, flare it, treat it, deodorize it. Highly impervious cover, active gas collection, flaring, treatment, utilization, methane oxidation. So we have different solutions for different problems. Out of these 30 waste dumps that we talked about, we did the relative ranking for 12 of them. These are the big waste dumps of the country. Now, I don't want to go into the relative ranking systems, but if I'm doing groundwater hazard, the important factors are depth to groundwater table, rainfall, and perviousness of the soil. So you please find in a 0 to 1000 scale, waste dump JKL have high impact. Probably the groundwater is shallow and the soil is pervious. They are probably in the Indo-Gangetic plain. I'm not showing you where these are. But other dumps may not be that bad. If I look at surface water contamination, same dumps, which had JKL had a high groundwater contamination potential, but here H has got high. Why? Because H is sitting next to a lake. It is on clay. It's on clay, it's not going to have a high groundwater impact. But the water will go off, clay will not allow the rainwater to come in, it's an open dump and it's sloping towards the lake, it will go into the lake. Or it's a freshwater wetland. I won't be surprised if this is the Dhapa landfill of Calcutta. The Dhapa landfill is sitting next to a freshwater wetland, which is called a Ramsay site, which is now almost protected like. So, and if I look at air, then Dhapa is remote, wetland, far away, or whatever this landfill was, it has become very low. Nobody around it. But these are the ones which are within the cities. If you are within the city, your air impact is very high. So different landfills in different geographical environments, subsoil environments will give you different ratings. So what do? I come back to my 7 systems. I can do local cover, municipal solid waste, hazardous waste, with gas recovery, with extraction wells, put in a new landfill, and mining. And these are your options. Local soil cover, municipal solid waste cover, hazardous waste, with gas recovery, groundwater extraction well, like this. So tell me, where will you adopt this? When will you adopt a local soil cover? Only a local soil cover. Even if it's low rainfall, so what? It can still contaminate. If it's on pervious ground and water table is at 2 meters depth, it will contaminate the groundwater. So one, it is remote, right? Two, it may be low rainfall area. Still, you don't want to contaminate the groundwater. So my answer to this is, if you have clay at the bottom, okay? If you have clay at the bottom, it becomes a natural barrier. If water table is deep below, rainfall is low, and you are remote. If you are not remote, if you are within a city, please understand what I am saying. You can put a local soil, but the smell will keep on coming out because it is coming out slowly. It won't come out that badly if there is no cover. So, if you have a remote dump sitting on clay, low rainfall area, away from a surface water body, you just put a soil cover and it will work. The same, if you bring it into the city, this will not work. When will you put a municipal solid waste cover? As I said, you put a municipal solid waste cover if a liner exists at the bottom. So if you have natural clay at the bottom, then you will design it like a new landfill. So a municipal solid waste cover can be used. But do remember, gases will still come out because this is not designed for greenhouse gas emission control. When will we use a hazardous waste cover? This is on clay, this is on clay, this is on clay. But if this is close to a water body, please understand, if this is close to a water body, in a municipal solid waste cover, leachate will be formed because it will not be completely eliminated. So it can go to the surface water body if the ground is sloping. So close to a water body, you are sitting on clay, just encapsulate it with a composite cover. That will prevent any water from going in and spoiling your thing. When will you use this? Active gas collection and flaring. Sitting on clay, but you are in a city. The residents will not tolerate bad odor because it depresses the real estate. In a city, if you have a bad odor dump, please take a 2-kilometer radius around that dump and all the real estate properties will be depressed. If the rate of selling the property is 10,000 rupees per square meter at a location X, the one which is close to the dump will be selling at 2,000 rupees per square meter. Who will stay there? Who will? मैंने अपनी सारी जिंदगी ये गंदे नाले के पास रहना है, right? So if you close it and you treat it and there is no odor, and this is on clay, this is inside a city. And when will you do this and not this? If by chance you are on pervious soil, then inside a city, then you have to add on the vertical cutoffs. Of course, finally you may want to say, no, I don't like all this. I don't know whether my vertical wall is made properly or not. I still have a risk. I want zero risk. Okay, then I'll make a new landfill for you with a leakage detection system and I'll put all the waste in it. Very expensive, but it's got to be done. So these are your levels of options for the rehabilitation. The problem here is once you close this, you can't put additional waste. And cities don't have additional land. So you have to build in expansion with your closure and rehabilitation option. So wherever the height is not very high, you can now look at what are the expansion alternatives. So let us say I have this much land. By God's grace, I have only filled this. Okay? So let's say this is 300 to 500 meters. My old waste dump is only here. Now clearly the moment I see this land, leaving the place for road and green belt and leachate pipe, I can see that this is what my landfill should look like. And typically it should be 15 meters only. 30 meters if you don't have any other location. So, one thing is very clear, I must use this space if I can. Now how do I use it? One option is contain this, whether by this or like this, whatever, but you do the containment as per the 7 alternatives which were given earlier. Now for your fresh waste you make a new landfill. It's a very not such a good technique. Why? You still have lost all this space which you could have utilized and all this space which you could have utilized. So this is alternative A. This is one technique which can be used, but only to be used if this waste height has become very long, very high. The other alternative is, okay, I'll pick up this waste from the low height area and I'll put it on top. Okay? So what will happen? More space will get released for the new landfill. I pick up this waste, put it on top, and close it as per the 7 alternatives that I have. That is a capped landfill. Now I have a larger landfill which emerges. So this is good. This is better than alternative A, right? But still I am not using the full space. I want to use the full space. Let's look at 3. Alternative 3 is I pick up the waste and put it on top and I close this landfill and I make my new landfill like this. Do you like it? This is a liner, this is the cover, this is the cover. I don't know what is this. This is all supposed to be a liner. So I can always make this like a liner, right? But the problem with this is it is leaning on this, and this is going to undergo biodegradation. Settlements will be large over the next 20 years. So this liner may have to settle a lot and it may undergo rupture or some kind of defects. So the liner may not function. So there is a risk involved in this. But now I have used my full space. Okay? Yet another alternative is, why should I waste the money to pick up this and put it on top, pick up this and put it on top and then do this? Let me do the following. This is called piggybacking. This is my old landfill. I will close it and I'll raise my new landfill on top of the old landfill. This is called piggybacking in America. Here it says piggybacking, very expensive, low reliability, not recommended, because this is going to settle. Suppose this is 10 meter high waste. If I am having settlements of 15 to 20% over the next 20 years, this will settle by 1.5 to 2 meters. If this settles, this liner will go like that, and I cannot tell you whether the liner will malfunction or not. Agreed? So this is piggybacking. It can be designed. You have to put 7 layers here. You can design for a very deep settlement also, but then it becomes prohibitively expensive. So that expenditure has to be compared with relocating like this expenditure. So this was alternative D. Are there more alternatives? Yes. Let me start a new landfill in this end. Okay, let me put a liner. Let me pick up this waste and put it in this landfill. Okay. And then as I have finished this entire waste here, then I move forward with the new waste. So in this, there's a liner completely below. Now any relocation of waste will create some odor. So the residents will complain while you are relocating the waste. Remember that. But it is something that you can do in 6 months. And then you have a completely, fully contained landfill. More expensive because you have to move all this waste from here to here. Finally, of course, the rehabilitation, the mantra of today. Take this waste, put up a mining unit. What is a mining unit? Dig the waste, dry it, use sieves, Normally the coarse fraction will either have boulder or cobble sized construction and demolition material, or it will have plastics and cloth and wood and cardboard and burnable material. So send some of the material for burning, some of the material for building materials. What will remain at the bottom in the fine fraction will be like compost or soil. This question is on. So if you can use all that material, the rejects will come, but now they will come in a much smaller area, right? And your new waste will also come through this plant, and you'll have, it will be accommodated in a smaller area. So these are the alternatives for closure with expansion, and all cities need this and not closure. So I'll give you the example of Garai landfill, which was closed, and there was a big problem because after that, where will the waste go? Then it went to Deonar. But this was a quick recap. This was the landfill. I've probably shown these figures to you. That is the leachate, that is the creek. And the idea was that this waste was about 15 meters high, 15 to 18 meters high. The slopes were very steep, and we thought we could put a cover like this. It was sitting on clay, but still some vertical cutoff walls were attempted. But the final solution was that this was too steep for the slopes to be, because there was a geomembrane in the cover. So therefore, we relocated this waste. So this slope was made flatter. Therefore, this went higher. So this 15 to 18 meters became 25 to 30 meters high, and you were able to make a stable landfill. But this is not expansion. So just to remember, this is making the slope flatter, and that is putting the cover on top, and these are the berms. And so it's a composite, you know. This is making the vertical cutoff wall. We will be doing this later, but you can, it's like a vertical diaphragm wall. There's your vertical cutoff wall at the base. The work is going on. And putting gas wells, you had, because you are putting a geomembrane, you were recovering gas from it. That's the gas flaring system. And that's how the landfill looks like in the end. Can't put in any more waste, much more flatter than what you saw in the beginning, but higher and greener. And you know, all around it you can see these houses. There were houses on this side also, very close. So while I was one of the consultants to the project, so the local, as I said, local estate agent said, जी आप यहाँ पे 2-3 फ्लैट ले लो, आपको तो पता है कि इसके बाद इसकी वैल्यू 2-3 times हो जाएगी. So being a professor, how to choose life? So being a professor, I didn't make that investment, but the cost of real estate went up 10 times in a year and a half. When this got capped, the odor went. There is still a little bit of odor, but there's no comparison to what it was earlier. And therefore, all the area now has got real estate around it. Can you see this? New buildings? Only if I had made some investments. The second example is Deonar, where it is expansion also. The waste dump is like this. Little bit area is lying here. Various alternatives were considered. You will close it. You will put the vertical cutoff soil, a vertical cutoff wall. You will make an additional landfill for the new waste, because there was some area. Or we will do piggybacking. Or I'll put the waste into this and then put the future waste like this. Or I'll put it here. You see, the difference is here you have to move more waste. Here you have to move less waste, and then my new waste will be like that. All these alternatives were tried, but finally I will move the waste here and make my new landfill. This is the one which was adopted. This was not adopted because nobody could give 100% assurance that this side slope liner will not fail because of a lot of settlement. So this is the final thing which was adopted. That was the topographic 3D view. This is what it is. This is the old dump which will close. These are the two new landfills. This is the compost plant and all that processing. I come back again. This is C. Can you see the C? like this. This is a C. This diagram is a ulta C, so please don't mind. If you look at it from that side, it's a C. So this old dump, all this waste will be picked up and put on this old dump, and new landfills will be developed here, and this will be the waste processing unit. So this is again the same thing, waste dumping developed. That's the old waste dump being, height is being raised. This is the new landfill being constructed. This went into dispute, and the operator moved off from the site, and there were a lot of fires later, last year and last year where you heard about it. But when these people were in control of the site, and we were also involved, there were no fires, and this was proceeding very wonderfully. And this is expansion with closure. So thank you. We've discussed a very major topic, because this is something which is, occupying us all. That how do you handle these huge old waste dumps? And really we want to gobble them up and utilize the waste. But what comes out from a landfill, is everything utilizable or it is not? That is the scope for discussion on landfill mining. And as more and more experience and more data comes available, we'll see whether towards the end of this lecture, end of this course, we can address that issue. At the moment, there is nothing that exciting that if I have 100% area, my landfill mining will give me 80% back. No. If you do landfill mining, 100% of the area may reduce to 70%. But you don't have very drastic reductions as of now. We'll stop here. Any questions? Anybody has some new thoughts, some new ideas as to what we should do with these beautiful old waste dumps, which are like, monuments of the city. Any city you go to, first ask them, "Mujhe apna garbage dump dikhao." Then only you say how good or bad a city is. Because if they manage the waste well, if they manage their sewage well, if they manage their garbage well, then it's a well-planned city. We'll stop here. Have a good day.